So repeating myself, if the active value of R is less than 1, then this infinite geometric series converges. And in particular, it converges to that. Now, if I take a peek at a function whose output is this, notice that this expression is nothing more than that expression, if with the latter I replace A and R with 1 and X respectively. So knowing what I know about a geometric series, I have a power series representation for that function. So this may seem completely unrelated, but if I'm on a desert island and I want to approximate pi, then let's see how I would do that. Let's approximate pi to maybe 0.5 units. Sorry, I didn't mean to write it up. It's not too sloppy. So here we go. Now, take a peek at how if I took this expression and replaced x with a negative x squared, please don't take this the wrong way. I'm not stacking equations suggesting to you, the reader, they're all equivalent. I'm just simply saying, take this relationship inside my fingertip and replace every single x you see with a negative x squared. Wouldn't you get this? Also press the if-then business. I said if-then. Also press the if business. Now, as I'm doing this, if you so choose, you can also, if you really want to, replace this using summation notation. A lot of people, when they do what I'm going to do, they keep everything in summation notation, and if they need an expansion, they write it all out in the end. I typically am going the other direction. I typically just keep it this way, and at the end, I write in summation notation. But this is my first example. Let me do it both ways in case you like this flavor first. Now, take a peek at how if I integrate with respect to x, I get this. I know how to integrate, so I think. And you know, everybody, I really think I'm wrong. I think I've committed a pretty grave mathematical sin. So let me fix that mathematical sin. Now, oftentimes I can't get rid of the C, but I gotta confess, in this example, life's a piece of cake. Not doing anything to both sides, but just look at the left-hand side. Is that nothing more than this? So knowing what I know about a geometric series, I think I can come up with a power series representation for the inverse tangent function. As a matter of fact, I get a little lucky here, because if you just take this one relationship right here, and you replace every single x you see with 0, the entire right-hand side drops out to be just a c. The left-hand side drops out to be a 0, so c is equal to 0. I got a little lucky in this example. Now, at this stage of the game, do you mind if I suppress the summation form of the power series representation for this function? Now, I want you to take a peek at something pretty darn interesting. Replacing x with 1. I don't know how many terms I needed. And replacing this with what it is. Oh, shoot, look at that. Now when I multiply both sides by 4, but notice how this term right here in absolute values is the first term less than 1/2. And so it is the case that if I merely use these first 4 terms as an approximation for pi, it'll be as accurate as the first unused term in absolute values, which is less than 1, which is what I asked for. I got lucky because it's an alternating series. Jeepers. Looks like we're getting a bit sophisticated.